Hello everybody, welcome to Transy Learning Physics videos. Today we are going to discuss about electrostats, and in that we are going to cover the topic electric charges and field. This is the part A of electric charges and field, and this is divided into different videos. So let's see what all we are going to cover in this part A. In this part A of electric charges and field, we are going to cover about the introduction about the charges, what is a charge and its units, types of charges, types of matter, and methods of charging like induction, friction, and conduction, and about gold leaf electroscope and how we can charge the gold leaf electroscope. So let's start. So first of all, the introduction. What is meant by electrostatics? Electrostatic, it is the study of forces, fields, and the potentials arising from the static charges. Static charges means the charges which are stationary. That means stationary charges are known as static charges. That means charges at rest. This can be positive or the negative charges. Now, what is an electric charge? Electric charge is the property associated with the matter due to which it produces and experiences electric and the magnetic effect. In that, when we are talking about the electric and the magnetic effect, we would be talking about the electric and magnetic fields as well as the forces associated with them. So, the basic concept about the charges is that like charges repel and the unlike charges attract each other, and this is as per the fundamental law of electrostatics. You can see here that this is positive charge and this is negative, so they are getting attracted towards each other, whereas a positive and the positive will repel and a negative and negative will repel. Please note there is a pictorial way of showing attraction and repulsion. Arrows towards, that is inward, shows attraction, whereas the arrows outward show repulsion. So you can see here the arrows are towards, it shows attraction, whereas here the arrows are outward, so it shows repulsion. Now, if we have to just talk about or say, what do you mean by static electricity? So, in one line, where electric charges remain stationary, and static electricity occurs best on the insulators. I have discussed about the insulators later in this video. Now, current electricity is when the charges are in motion, it occurs in the conductors. You can see here that here you have the positive charge on one insulator, and this is negative charge. So here the charges are at rest. So it's static electricity. But in this case, the charges are in motion. This is positive and the negative. And in this case, there is a flow of electrons. So that means the charges are in motion. So it represents your current electricity. Now, the units of charge. There are always two units of any parameter, that is the SI unit and CGS unit. So the SI unit of charge is coulomb, which is represented by C, and the CGS unit of charge is ESU, which is known as stat coulomb, and it is represented as ESU. Now, what is the relation between the SI unit of the charge and the CGS unit of the charge? So 1 coulomb is equals to 3 into 10 raised to power 9 ESU, that is stat coulomb. So this is the relation you can remember. And please remember, when we are dealing with any parameter, there are higher values as well as the lower values. So when the power is negative, it shows the lower values of any parameter. In this case, we are talking about the charge. Small m and c says the millicoulomb. And then we have the microcoulomb. Micro is 10 raised to power minus 6. Nanocoulomb, that is nano is 10 raised to power minus 9. And picocoulomb, pico is 10 raised to power minus 12. So when we have to deal with the smaller units, we always consider the units with the negative power, because the negative power represents a smaller unit. On the contrary, the positive powers explains the bigger units. So now attractive and the repulsive forces. As I've discussed, that when the arrows are inward or when the arrows are towards, that shows the attractive forces, whereas when the arrows are outward or away, that shows the repulsive forces. So you can see here, this is one glass rod and this is another glass rod. Both of them are positively charged. And you can see that this arrow are outward showing the repulsive forces. Whereas in this case, we have a glass rod and one is the ebonite rod. One is positively charged and one is negatively charged. So there will be attractive forces which are pointing towards or the inward. So in this case, when two charged rods are with the same sign, that is positive, there will be repulsive forces. And when they are of different sign, like here in the B figure, then there will be attraction towards each other. Now, in this video, I have given you the list of the substances which will acquire the positive charge and the negative charge. So the bodies which will acquire positive charge is the human body, glass, mica, nylon, wool, silk, aluminium, polyester, and the paper. And the bodies which will acquire the negative charges is cotton, steel, copper, rubber. Then we have the vinyl chloride and the silicon. Now the question arises that why some bodies acquire positive charge and some bodies acquire negative charge. This is a question, this is the basic question that we need to understand in order to know that which body will acquire positive charge and which body will going to acquire negative charge. So let's start. Now let us understand that how a body acquires positive charge and negative charge when rubbed. So you can see here that there are two bodies. Body B is of comparatively bigger size and the body A is of comparatively smaller size. Before we understand the concept, we need to understand two parameters. First is the electrostatic force of attraction, which I'm going to write it as EFA. And the second is the relation between the force and the distance. So the attractive force between the positively charged nucleus and the valence electrons is known as the electrostatic force of attraction. You can see here this attractive force between the nucleus and this valence electrons is the electrostatic force of attraction. And in this case, this is the nucleus and this is the valence electron. So this is electrostatic force of attraction. Now the second parameter is the inverse relation between the force and the distance. What does this mean? This means that with increase in distance, force decreases and vice versa. So if the distance increases, the force decreases, and if the distance decreases, the force increases. Now, let us compare two bodies. First of all, the body A. You can see this is the body A. In this case, the distance between the nucleus and the valence electrons is less as it has a smaller size. Okay, so you can see here that out of the two bodies, body A has a smaller size and the distance between the nucleus and this valence electrons is less. So due to that, the electrostatic force of attraction will be comparatively more in body A. As I've told you that the force is inversely proportional to the distance. While if you see the body B, in this case, the distance between the nucleus and the valence electron is comparatively more as it has a bigger size. So the electrostatic force of attraction will be comparatively less in the body B because the force is inversely proportional to the distance. So now if we compare these two bodies, we can say that the distance between the nucleus and the valence electrons is more in body B as compared to the body A. So the electrostatic force of attraction in body A will be more than the electrostatic force of attraction in the body B because the distance between the nucleus and the valence electrons in the body B is more as compared to the body A. So this is the basis which will help us to understand why one body loses electron and the other gains. So first of all, let us consider what happens before rubbing. So here you can see that these bodies are a little bit distant apart, so they are not rubbed right now. So what is the charge on these bodies before rubbing? So before rubbing, the body A as well as the body B, both of them will be neutral. This means that the total positive charge is equals to total negative charge. That means the total number of protons will be equal to the total number of electrons. And in body B also, the total number of protons will be equal to the total number of electrons. So that means both the bodies before rubbing are neutral. So now when a body A is rubbed with a body B, due to the friction, heat is produced. You can see that this heat is produced. The heat is sufficient for an atom to lose electrons. Now the question arises, out of A and B, which body is going to lose electron and which body is going to gain electron? So what will happen after rubbing? The body A will acquire negative charge. Due to small size of the body A, the electrostatic force of attraction is more in the body A as compared to the body B, right? So the body A will not lose electrons easily, rather it will gain and acquire the negative charge, whereas body B will acquire the positive charge. Due to the bigger size of the body B, the electrostatic force of attraction is lesser in body B as compared to the body A. So the body B will lose electrons more easily to body A and acquire the positive charge. So in that case, this body B will lose electrons because here the electrons are comparatively loosely bounded, and the body A will gain electrons because here the electrons are little bit more tightly bounded because of the more electrostatic force of attraction as compared to the body B. So thus the body B becomes positively charged and the body A becomes negatively charged after rubbing. So this is the summary that I have talked about, that before rubbing, the total positive charge and the total negative charge is same in both the bodies. But on rubbing the two bodies, the body with the bigger size will lose electron and the body with the smaller size will gain electron. So the body will get positively charged and the body A will get negatively charged. Now, earlier I have talked about positively charged bodies and the negatively charged bodies. This is the list. Now, let us consider one case of a glass rod and the silk cloth. Let us rub the silk cloth against the glass rod. Now, before rubbing, you can see here that the silk cloth is also neutral and the glass rod is also neutral. Now, when I'm talking about neutral, I mean that the total positive charge is equals to total negative charge. Here also the total positive charge is equals to total negative charge. And after rubbing, we can see here that the glass rod acquires positive charge and the silk cloth has acquired negative charge. Now you can very well tell why, what is the reason the glass rod has acquired positive charge. Because the glass rod will lose electrons and the silk cloth will gain electrons. Now, why the glass rod will lose electrons? Because it will have comparatively less electrostatic force of attraction because of its larger size as compared to the atoms of the silk cloth. In this case, the silk cloth will have a smaller size and it will have comparatively more electrostatic force of attraction. So it is going to gain electrons more easily. So on rubbing, the glass rod will lose electrons and the silk cloth will gain electrons. So now you know the basics, that the one which loses electron has comparatively larger size and have comparatively less electrostatic force of attraction, where the substance which gain electrons has a comparatively smaller size and comparatively more electrostatic force of attraction. So in this case, the silk cloth will gain electron and the glass rod will lose electron. So that I was telling you earlier, that you have to see the comparison when you are rubbing two bodies against each other. So now these are again the list of the substances which will acquire positive charge on rubbing and negative charge on rubbing, like the glass rod, cat skin, woolen cloth and the woolen coat will acquire positive charge, whereas the silk cloth, ebonite rod, amber rod and the plaster seed will acquire the negative charge. Now if I take the cat skin and I rub it with the ebonite rod, this is my ebonite rod. Now the ebonite rod will acquire negative charge and the cat skin will acquire the positive charge. So in this case, now you know that the cat skin will lose electrons. Why it is going to lose electrons? Because it will have comparatively larger size and the electrostatic force of attraction will be less. So it can lose electrons easily as compared to the ebonite rod. Whereas the ebonite rod will gain electrons because it will have comparatively less size of the atoms and the electrostatic force of attraction will be comparatively more, so it will gain electrons. So that was the concept, that how and why one body acquires positive charge and the other acquires the negative charge. Now, let us talk about the conductors or the matters. Now, according to the flow of the charges, there are three types of matter. First is the conductor. The substances through which electric charges can flow easily are called the conductors. You can see here that this is a conductor through which the charges are flowing very easily. In that case, the electrons are moving from the negative to the positive, whereas the current is flowing from the positive to the negative. Insulators, the substances through which electric charges cannot flow, like the rubber, glass, oil, or wood. Then we have the third type, semiconductor. Those substances which can behave as insulator at low temperature and as conductor at high temperature. So the semiconductors behaves as insulators when the temperature is below 0 Kelvin, and they behave as conductors when the temperature exceeds 0 Kelvin. That means with increase in temperature, the conductivity of the semiconductors increase. Now, here we are talking about the conductors and the insulators. One important point worth noting is that when some amount of charge is given to the surface of conductor, then due to the property of conduction, that charge is distributed uniformly at the surface of the conductor. So if you give some charge on the conductor, that charges are going to distribute equally on the surface of the conductor. Whereas in the case of insulator, when some amount of charge is given to the insulator, then due to the property of the non-conduction, charges does not get distributed to its surface. So you can see here that the charges are accumulated here only. So they are not going to distribute, they will remain at the same point. This is the main important concept about the conductors as well as the insulators. Thank you very much for watching this video. Now the part 1 of part A ends here. In other videos, that means part 2, 3 or 4 of this part A, we have covered the topics like charging by friction, how we can charge uncharged conductor positive or negative charge using the friction, using conduction, using the process of induction, and what is a gold leaf electroscope, what is its purpose, for what purpose it is used, and how we can charge the gold leaf electroscope. For more videos, you can visit our YouTube channel, that is Trans E Learning. Have a great day.